Hello students, once again in class 12th, the P block elements, we were discussing group 15 elements, and in this video we are going to discuss about preparation, properties and usage of nitric acid, and we will also discuss about the brown ring test. Okay, first come to the nitric acid. Actually nitrogen forms oxo acids like this is H2N2O2 hyponitrous acid. This is its formula. HO single bond N double bond N single bond OH hyponitrous acid. Actually this is the dimer of HNO. Okay, HNO2 nitrous acid, and this is the formula of HO single bond N double bond O, and nitric acid HNO3, and this nitric acid is the most important, and this is the structure of nitric acid. This is nitrate ion NO3 minus. Okay, and there is a resonating structures, you can say double bond may be here and double bond may also be here. Okay, preparation of nitric acid. In the laboratory, nitric acid is prepared by heating KNO3 or NaNO3 and concentrated H2SO4 in a glass retort. This is a glass retort, such type of flask is there. Reaction is NaNO3 plus H2SO4 gives NaHSO4 plus HNO3. This is laboratory preparation. And on a large scale, it is prepared mainly by Ostwald process. Okay, now what happens in Ostwald process? This method is based upon catalytic oxidation of NH3 by atmospheric oxygen. It is ammonia from atmosphere react with the oxygen. In the presence of these catalysts, this condition of temperature and pressure, it forms NO. Okay, this nitric oxide thus formed combined with oxygen giving NO2. This 2NO plus O2 gives 2NO2. And this nitrogen dioxide so formed dissolve in water to give HNO3. NO2 plus H2O gives HNO3. Okay, this NO produced is again further used in this reaction. Properties of nitric acid. It is a colorless liquid. Boiling point and freezing point are these. Freezing point is 231.4 Kelvin. Boiling point is 355.6 Kelvin. Laboratory grade nitric acid. It means nitric acid which is supplied in the laboratory. It contains 68% of HNO3 by mass. This we can say this is the purity of this HNO3 supplied in the laboratory, and its specific gravity is 1.504. In gaseous state, HNO3 exists as a planar molecule. We have already discussed the structure of this. In aqueous solution, nitric acid behaves as a strong acid, giving hydronium ion and nitrate ion. HNO3, when dissolved in the water, it forms H3O plus and NO3 minus. Concentrated nitric acid is a strong oxidizing agent and attacks most metals except noble metals such as gold and platinum. Noble metals means least reactive metal. Okay. The products of oxidation depend upon the concentration of acid, temperature and nature of the material undergoing oxidation. Dear student, this is the important part of this topic. That is, we can say that is product of metal with the HNO3 depends on the which metal we are using and what is the concentration of HNO3. See the example, like copper we are taking in two different situations. Copper, when this react with the dilute HNO3, it will produce copper second nitrate, and this is NO, nitric oxide gas is produced with the dilute HNO3. But when we take the concentrated HNO3, this is the same, but difference is this is nitrogen dioxide gas is produced with the concentrated HNO3. Now if we change the metal, now in place of copper we are taking the zinc. With dilute HNO3, this will give the zinc nitrate and this will form nitrous oxide N2O. Okay, and with concentrated HNO3, this will give nitrogen dioxide NO2. Is it clear? So these are the important reactions. Some metals, for example chromium and aluminium, do not dissolve in concentrated nitric acid because of the formation of a passive film of oxide on the surface. Actually, aluminium oxide and chromium oxide is deposited on the surface of aluminium and chromium respectively, and these aluminium oxide and chromium oxide is passive towards the reagent. Okay, but concentrated nitric acid also oxidizes known metals. See, iodine is oxidized to iodic acid. This is I2 when react with the HNO3. This is HiO3. This is iodic acid. Okay, and HNO3 itself convert into NO2. Carbon convert into carbon dioxide. This is CO2, and again HNO3 will convert into NO2. Sulfur to H2SO4. This is sulfur is oxidized to H2SO4 and HNO3 will convert into NO2. Phosphorus will oxidize to phosphoric acid. P4 phosphoric acid is H3PO4 and this HNO3 is converting into NO2. Clear? Brown ring test. Dear student, this is the most important test in the chemistry laboratory will also there. Okay. The familiar brown ring test for the nitrates depends on the ability of Fe2 plus to reduce nitrates to nitric oxide, which reacts with Fe2 plus to form a brown colored complex. Okay, that is Fe2 plus convert nitrate into nitric oxide, and then this nitric oxide react with Fe2 plus form to Fe2 plus and form a brown colored complex. Then how we will carry out this test? This test is usually carried out by adding dilute ferrous sulfate solution to an aqueous solution containing nitrate ion. It means first we will take the one salt containing the nitrate ion, make its aqueous solution, then we add the dilute H2SO4 and then carefully add concentrated sulfuric acid along the sides of the test tube. Okay, when these two solutions will meet, then a brown ring of penta aquo nitroso iron second sulfate at the interface between the solution and sulfuric acid layers indicates the presence of nitrate ion in solution. You can see this. This is the brown ring is formed like this. Okay. Now reactions are taking place. This is nitrate ion, Fe2 plus react, and this nitrate ion will convert into NO, and Fe2 plus will convert into Fe3 plus. But some of the unreacted Fe2 plus react with this NO and this form a one brown colored complex. And what is its name? This is penta aquo nitroso iron second sulfate. Okay, this is famous brown ring test. Usage of nitric acid. Okay, what are the uses? The major use of nitric acid is in the manufacture of ammonium nitrate for fertilizers and other nitrates for use in explosive and pyrotechnics. It is also used for the preparation of nitroglycerin, trinitrotoluene and other organic nitro compounds. Other major usages are in the pickling of stainless steel. What is the meaning of? We will discuss pickling, etching the metals, and as an oxidizer in the rocket fuel. Now, what is the meaning? What is the meaning of this pickling? Pickling is the removal of a thin layer of metal from the surface of stainless steel. You can see from this diagram. This is one container of stainless steel. Okay, this is before pickling and this is after pickling. Whatever this metal is there, this is removed when this is treated with the nitric acid. Okay, and what is the meaning of this etching of metals? Etching, this is traditionally the process of using strong acid to cut into the unprotected parts of a metal surface to create a design in the metal. You can say this. This is the diagram representing the etching of the metal. Clear, students? Thank you.